I'm going to read something from a little treatise called Structure of the Universe. And it's probably quite long. It'll be in two parts. And I hope if you listen to this, you'll understand why I'm reading this. It's to counter what I perceive as a tsunami of BS about things that are happening in the celestial realms. So I'm going to read slowly. So I'm going to treat it like a bedtime story. Okay. There's much more around this. There's a big lead up to this, which definitely would need visual aids, and it's not really germane to what I'm trying to get across right now. I hope you have fun, or 10 minutes to spare. Now, because the Milky Way is a spiral nebula, when we face Sagittarius, we address ourselves towards the center or source of its creative energy. That is the nebula. Just as when we face the sun, we address ourselves toward the center or source of the creative energy of the solar system. So also, when we face Gemini, we face away from the center, as at midnight we look up into that part of the heavens in opposition to the sun. Here then is an objective measure for the long-believed characters of the zodiacal signs. They are in fact a measure of our inclination towards the focus of our galaxy, as definite as the hours of the day are of our inclination towards the sun. So why I'm bringing this up at these ages, which are about 26,000 years long, have flavors to them, like hours of the morning and hours of the afternoon and sunset. Each one has a flavor that lasts for 26,000 years. When the sun is in Sagittarius, it means that the solar radiations and any unknown higher radiations from the focus of the Milky Way reach us from the same direction or are in conjunction. When the sun is in Gemini, it means that the solar and galactic radiations reach us from opposite directions. And when we face the sun in the intermediate signs of Virgo or Pisces, it means that we see it against outer emptiness or against the invisible past and future of the Milky Way, whose central radiation reaches at right angles to the solar rays. At present, we cannot specifically state the nature of the radiations which may be given off by the galactic center, but a general radiations of a few meters wavelength has been detected, which is notably stronger in the direction of the densest star clouds in the Milky Way, and strongest of all in the direction of Sagittarius. This radiation is now regarded as a definite characteristic of our galaxy, and particularly of its center, whose physical nature is hidden from us by star clouds. It is distinct from, but similar to, what have been known as cosmic rays, which, reaching the Earth from all angles and directions, and being of higher frequency than any known to originate in the sun, must also convey to us matter or influence from the vital center of some even greater world. This same author has said that the sun is actually like a planet, and that it's receiving so much light from a higher world that we can't detect with our senses, but when it hits the sun, it bounces off and we get that intense overload of impressions from the sun. We have posited this next greater world or cosmos above the solar system to be the Milky Way, but there are many indications that the gap in size here is impassably great. Later, when we come to measure the relative sizes and dimensions of the cosmoses which we have been able to identify, we shall see that the factor of multiplication between the solar system and the Milky Way is far greater than that between cell and man, between man and nature, between nature and earth, or between earth and solar system. The solar system seems lost in the distances of the Milky Way, as a single man would be lost on the surface of the earth, were it not for the orderly world and nature of which he forms a part and which mediates, so to speak, between him and it. The diameter of the earth, for instance, is 1/millionth that of the solar system. But the diameter of the solar system is only perhaps 1/40 millionth that of the Milky Way. When in our own system we find such relationships, it is not between sun and planets, but between sun and satellites of planets. That is to say, by analogy of scale and mass, we should expect the solar system to be revolving about some greater entity, which in its turn was revolving about the center of the Milky Way, just as the moon revolves about the earth, which in turn revolves about the sun. What and where is this sun of our sun? Several attempts have been made to discern a local system within the Milky Way, particularly by Charlier, who in 1916 seemed to have established such a group 2,000 light-years across and with its center several hundred light-years away in the direction of Argo. If we study our immediate surroundings in the galaxy, we find an interesting gradation of stars, two of which are suggestive from this point of view. Within 10 light-years we find one star similar in scale to our Sun, and Sirius over 20 times as bright. Between 40 and 70 light-years distance we come on 5 much larger stars, 100 to 250 times brighter than our Sun. Between 70 and 200 light-years, still 7 greater still, 250 to 700 times brighter, and between 300 and 700 light-years, 6 immense giants, tens of thousands of times more brilliant. The greatest of these, Canopus, which lies 625 light-years behind in the exact wake of the solar system and is 100,000 times more radiant than our Sun, could indeed be the sun of Charlier's local system. But as in so many of these problems, it is only when we abandon astronomical theory and return to direct observation of the sky and heavenly bodies that we find a more immediate starry influence to which the solar system must be subject. For the most brilliant object in the heavens after those within the solar system itself is of course the double star Sirius. This consists of an immense radiant sun 26 times more brilliant than our own, which circles in a 50-year period with a white dwarf as big as Jupiter and 5,000 times denser than lead. The mass of the light star being 2.5 times that of our Sun, and that of the dark one equivalent to it. The influence upon the solar system of this starry pair, which lie at less than 9 light-years removed, must certainly far exceed that of any other extrasolar body that we can think of. By physical distance, as by radiance and mass, a Sirian system would seem in some way to fit the excessive gap between the cosmoses of the solar system and the Milky Way. Indeed, the distance from the Sun to Sirius, 1,000,000 times the distance from Earth to the Sun, falls naturally into the scale of cosmic relationships mentioned and provided 19th century astronomy with an excellent unit of celestial measurement, the Siriometer, now, unfortunately, abandoned. I'm going to go on to part 2 because I'm running out of time. Hopefully this will give us a different view on the small stars coming into our system here.